So now that we know how to measure and create an experiment in psychology, there are some things we need to keep in mind and some potential downfalls that can come to experimenters. So one thing you want to keep in mind is demand characteristics. And this is aspects of an observational setting that could make people behave as they think they should. So I talked about this a little bit in naturalistic observation, but it also plays a role in measurements for experimental psychology. So, like I mentioned, this is a problem for both clinical and scientific settings, because sometimes people will, even when they go to, say, therapists, then they will say what they think the doctor wants to hear rather than being honest. And so these demand characteristics can hinder scientific research, but they can also hinder treatment or just therapy sessions for individuals as well. So this is, again, answering questions or changing your behavior based on what you think the experimenter wants. So this could be in a survey, not indicating particular habits that you think the experimenter would find unpleasant, or would it be socially acceptable. It's kind of like when people say, like, oh, how you doing? And people are just like, oh, I'm fine. And they're not fine. You're saying that because that's what you think people want to hear. So how do we avoid these demand characteristics? So we can reduce demand characteristics by ensuring participants of their anonymity and their confidentiality. So a lot of times what we do is when someone comes in to conduct research for us, then they're given a number. So rather than having their name associated with their survey or their data, then it's just a random number so that the participant feels confident that anything they do will be confidential and can't be traced back to them. And it really helps ensure that, one, the participants feel comfortable, but also that the data is reliable, because the participants aren't changing their behavior or their responses based on what they think we want to see. So you also want to use measures sometimes that aren't susceptible to demand characteristics. So there's some things people just can't change. So that would be like if you do a study using an fMRI or a skin response to test sweat or something. People can't really control that, right? You can't control the amount of sweat you produce in response to something. You can't really consciously change how your brain is working and firing in response to something to change it. So sometimes just changing how you're measuring or what question you're asking will help you avoid demand characteristics. Another thing that some researchers will do is they'll actually use deception. And what we do this is we tell participants that we're going to measure one thing, and then we're actually measuring something else. So what you have to do there is you have to develop a plausible cover story for what you're studying. So say we're going to measure, we want to measure how well someone is studying concentration. But what we're going to do is we're going to tell the participant that we're measuring the number of times they blink their eye. So someone can still be concentrated on something, but to them, they think we're counting how many times they blink their eyes rather than, say, they're looking around the room. So they won't change how they look around a room because they're too focused on changing how they blink their eye or something, So that's kind of deception. And then you can also measure a behavior that you know is related to the characteristic of interest, but the participant doesn't. So a lot of times we'll get very creative with things like that. And then another thing you can do is include some things like filler items. In other words, we will say have participants say play a video game and then stop halfway through and make them do some math problems and then have them play some video games again. And then again have them do math problems at the end. And what we'll tell them is, oh, we're testing your math ability or something after playing video games. Where really what we're doing is we're doing, say, eye tracking on the video games or their accuracy on the video games, and the math problem actually has nothing to do with it. But because we tell them it's about the math problems, then it doesn't change how they do on the video games. Now, a key thing to using deception or filler items is after the study is done, you always then can tell people, tell the participants what you are actually doing. So you always have to tell the participants the truth at the end of a study, so we can deceive you during the study, but once it's done, then we have to tell you the truth. So this is how to avoid the participant biasing the results, but what about the experimenter themselves? So a lot of times what researchers have to keep in mind is observer bias or experimenter expectancy bias. And so this is sometimes when scientists are creating a study, obviously we want a really good result. We want to prove our hypothesis right. But sometimes in trying to do that, then we can bias the results ourselves. So we need to do things to help avoid that ourselves. And this can be a conscious influence or also subconscious influence. And this could be influencing the participants' response or behavior as well. So our expectations can influence the measurements. So sometimes we'll only see what we want to see. We won't see the negative results because we don't want to. Our expectations can also influence reality. So we can unconsciously cue participants to respond how you want them to. So an example here could be really a problem when measuring ambiguous behavior. So the person was reaching for the cupcake or attempting to scratch their nose. So someone starts to do a behavior and then stops, and the experimenter could, they want to see that the participant was reaching for the cupcake, when in reality they were reaching to scratch their nose, but because they stopped this behavior halfway through, the experimenter has to make a decision. So bias can influence what we mark down that behavior as. Another thing is, say, when you're influencing reality, an example would be if a researcher is looking very concerned when discussing symptoms with a patient that's on a drug trial placebo group. By looking extra concerned for this participant, it may actually stress them out and make their afflictions progress more quickly. And what that would do is then kind of show that the placebo group isn't, obviously, you aren't seeing that treatment effect. So you could actually affect the results that way. So how do we reduce this observer bias, experimenter expectancy effects? One of the big ones that we use is a double-blind study. So a double-blind study is when neither the researcher or the participant knows which treatment is which and which group they're in. So opposite of that would be what we call a single blind study. And that's when the researcher knows what group each participant's in, but the participants don't know. So a lot of times this will be a drug study. So the researcher will give participants either the drug or the placebo. Participants don't know, but the researcher obviously does. And single blind studies are good to reduce demand characteristics, but it does nothing to really reduce observer bias. So that's why a double-blind study is good, because neither the researcher knows nor the participant knows. So you're reducing the expectancy bias as well as the observer bias. So you can do this with a drug placebo experiment where the researcher won't know, and the researcher will just give all the drugs to, say, a nurse, and the nurse will give them out. But then when participants come in for their checkups, they'll meet with the researcher and not the nurse. So that's how you would do it. So therefore, the researcher still doesn't know what group the participant's in. Participant doesn't know what group they're in. You can also reduce observer bias by using automated measurement devices. So this is pretty much just using a computer to measure responses rather than humans. By removing the human element, obviously you can't have observer bias. Another great thing that you need to do when doing experiments is random sampling. So we talked about this a bit. We talked about sampling, what makes for a good sample. Remember, we want it to be representative of the population. Now, random sampling is more like an advanced sampling technique. So random sampling is a technique for choosing participants that ensures that every member of a population has an equal chance of being included in the sample. So in other words, this would be kind of like putting every single participant, put all of their names in a hat, and then you draw names out of the hat. So everyone in the population has an equal chance of being picked. Now, of course, this isn't always possible. A lot of times studies are conducted at universities, and so our sampling group is based on students at the university, but then we'll draw conclusions about the population overall. Now, of course, the people that go to university aren't usually a representative sample of the entire population of the world. So that's something you've got to keep in mind, but random sampling does make sure that everyone has an equal chance of being included. So sometimes the similarity of a sample and a population doesn't matter. In other words, sometimes the question, it doesn't matter if the sample is representative of the population or not. So that's where random sampling can be really good. Also, sometimes experiments will be conducted multiple times. So by doing random sampling, it ensures everyone has a possibility of being included. And by running the experiment multiple times on different samples, increases the generalizability of the findings. Also, by doing random sampling, sometimes you do get a nice similarity between the sample and population. And by doing random sampling, then it really helps with the replicability of your results. Now, after random sampling, you've got this thing called random assignment. So random sampling is choosing who's going to be in the experiment overall. Random assignment is referring to picking who's going to be in each group. So whether they're going to be in the experimental group or the control group. So this would be like after picking everyone in the population's name out of a hat, you have your group. So we'll call that our sample. And then you're only going to put the sample's names in a different hat, and you're going to draw them out one at a time. And the first half that you draw out will be in group A, and the second half you draw out will be in group B. So that's random assignment. So it's a procedure that uses a random event, such as drawing out of a hat, to assign people to the experiment or control group. So that's where we're going to end for today. And then on Friday, we're going to cover examining data, so statistics, as well as ethics.